Chapter 2 is analyzing data. Every time we do a lab, we will be collecting data, so we need to know what to do with that data. There are 4 sections in this chapter. The main idea of the chapter is chemists collect and analyze data to determine how matter interacts. We are working on section 1, units and measurement. Okay, the objectives for section 1. Define the SI units for length, time, mass, and temperature. Explain how adding a prefix changes the unit. Compare derived units for volume and density. Review vocab. Mass, a measure that reflects the amount of matter an object contains. Remember, we talked about the difference between mass and weight. Weight has to do with gravity. Okay, new vocab. Base unit, second, meter, kilogram, Kelvin, derived unit, liter, and density. Main idea in section 1. Chemists use an internationally recognized system of units to communicate their findings, called the International System of Units. Okay, when you take a measurement, okay, these are some examples: checking your weight, reading your watch, taking your temperature, or weighing a cantaloupe. Okay, when we measure, we use some kind of tool to compare some dimension to that standard. Examples of tools: we have a graduated cylinder, a stopwatch, a thermometer, a measuring cup, and a scale. Okay, from the previous slides, which tool would you use for temperature? Which ones would you use for volume? Which ones would you use for time, and which ones would you use for weight? And there are your answers. Okay, so as I said before, in chemistry we do experiments and we collect data. Okay, collecting that data, we measure quantities, and we need those quantities to analyze what we're trying to answer in the lab. So we need to be comfortable with those measurements. In the U.S., units are different than the International System of Units. So in the U.S., what do we use for length, volume, weight, and temperature? Okay, so length we use inches, feet, yards, miles. Volume we use cups, teaspoons, gallons, pints, quarts. Weight we use ounces, pounds, and the temperature is usually in Fahrenheit. However, in the metric system, or in the International System of Units, length we measure in meters, volume is measured in liters, mass is measured in grams, and temperature is measured in Celsius. The United States really should move to the metric system. We are one of the only 2 countries that do not. Basically, the reason is we're lazy and Americans don't want to learn how to do it. But if you go to any other country, they do things in the metric system, so it's good to know. Okay, so the International System of Units is an internationally agreed upon system of measurement. A base unit is a defined unit in a system of measurement that is based on an object or an event in the physical world and is independent of other units. Okay, so time is second, length is meter, mass is kilogram. Be careful with that one. It's kilogram, not gram. Temperature is in Kelvin. We don't have instruments that measure in Kelvin, so we use Celsius, but the SI base unit is Kelvin. Amount of substance is mole. We will use that more. I believe it's chapter 10. Electric current is ampere, and luminescent intensity is candela. Okay, so here are some of the base unit definitions. When you use second, it is based on the frequency of radiation given off by cesium-133 atom. Okay, so that's how they determine what a second is. The meter is the distance the light travels in a vacuum in that specific amount of time. Okay, so that's how they determine what a meter is. And a kilogram is about 2.2 pounds. So there is a specific standard of measurement that each of these are. Okay, Kelvin, we specifically in our lab don't have instruments that will measure Kelvin, but we can convert between Kelvin and Fahrenheit and Celsius. Okay, 0 Kelvin is the point where there's virtually no particle motion or kinetic energy. It's also known as absolute zero. Okay, you can also use, as I said, Fahrenheit and Celsius. We will be using Celsius for everything that we do, and you can see on the right here where they compare the two. Okay, every time you take a measurement, you have a number, but that number has to be followed by a unit. You'll hear me once in a while, you'll say it's 62, and I'll say, is it 62 elephants? Is it 62 cars? You need to have a unit following your number. Okay. Okay, so there's your answer for that. I'm going to let you go ahead and read those. Okay, prefixes and equalities. So in the metric system, everything increases or decreases by a unit of 10. You have kilograms, hectograms, milligrams. Okay, you probably recall hearing the words kids have dropped over dead converting metrics. And I know we did this when you guys were in middle school, and I know you did this in math. So this should be mostly a review. So you can see down here at the bottom that there are, a kilo means 1,000, so there are 1,000 meters in 1 kilometer. Okay, so we probably won't be using giga, but it's good to know because giga is used more and more as the computers can hold more and more information. So you have giga, mega, kilo, and then below, smaller than 1, would be deci, centi, milli, micro, and nano. Okay, and then there they are all together in one table for you. And you need to know how to convert between these units. Okay, see if you can answer these questions. Okay, state the same measurement for the two different lengths. Okay, you can see the top one is in inches and the bottom one is in centimeters. So if you followed this green line down and you measured it exactly, what would it be in centimeters? What would it be in inches? And you can see that 10 inches equals 25.4 centimeters. So we can use this. When you pick up a ruler, it will usually have inches on one side and centimeters on the other. Okay, so 1 meter equals 100 centimeters. So centi is 100th. Okay, these are conversion factors that you'll get to know. Okay, a derived unit. Whoops, let me go back. Not all quantities can be measured with SI base units. Sometimes we have to combine some base units together to get a unit that we need. A unit that is defined by a combination of base units is called a derived unit. And the easiest one, or the one that comes to my mind first, is volume. When you take the volume of something, you take the length times the mass times the height. Okay, so you have 3 units together. Okay, usually meters. Okay, So the volume is measured in cubic meters, or sometimes you can do it in centimeters, but this is very large. More convenient measurement is a liter, or 1 cubic decimeter. So length times width times height gives you volume. Another one would be area, length times width. That is also a derived unit. One that we're going to be doing a lab on is density. Density is a derived unit of mass divided by volume. Okay. Okay. See if you can answer these questions.